So trigonometry, right? So in trigonometry, firstly, we will start from what we know. Grade 8 math. So you have this angle, theta, and the hypotenuse is r. So if you have that, so this side is going to be r sine theta, yeah? And then this is going to be r cos theta. That we know.
Yeah.
Now, what we are going to do, we will use Pythagoras theorem here. We will use Pythagoras theorem here. So Pythagoras theorem is r squared is equal to r sine theta squared plus r cos theta squared. Yep. So now simplify this a little bit. So it's going to be r squared sine squared theta plus r squared cos squared theta and r squared is here. So simple Pythagoras theorem. Now what we can do, we can take r squared out from the right hand side. So if I do that, sine squared theta plus cos squared theta, and that is r squared. Yep. Then you can see r squared has gone. So it's going to be 1 is equal to sine squared theta plus cos squared theta. So this is our first relation. Even for methods we need this.
Yeah.
So now this tells you, right? This tells you this. Example. Theta can be anything. Theta can be anything. Meaning, this is true if theta is equal to any number like sine squared pi divided by 4 plus cos squared pi divided by 4 is equal to 1. If you have sine squared pi divided by 6 plus cos squared pi divided by 6 also 1. So likewise for any angle this would work. Another example. Suppose theta is not just theta, theta is 2 theta, for example. So some angle. Then here it should be cos squared 2 theta 1. Right? Okay, so now we understood that. Now some notations. Notations. So we know that from grade 8, we know reciprocal functions, right? We know reciprocal functions, right? So what is a reciprocal function? If fx multiplied with gx, another function, if that is equal to 1, we call it fx comma gx are reciprocal to each other. Right. So this also means that fx can be written as 1 divided by gx. Right? So this is well known. Now when it comes to trigonometry, in trigonometry, we'll see how this works. You know, we know sin x function or sin x or sin alpha, or doesn't matter, right? What would be the reciprocal function of this? What is the reciprocal function
1 over sin x.
of this? Exactly. So it would be like this, sin x multiplied with another function, suppose gx, right? And that should be equal to 1. So this g is the reciprocal function, right? So obviously you're right. So gx is equal to 1 divided by sin x, right? So this 1 divided by sine x, the whole thing is given a name which is called cosec x. So 1 divided by sine x has a name cosec x. That's it. Right? So sine x multiplied with cosec x is equal to 1. Because gx becomes cosec x. Gx becomes cosec x. Clear? Now, now we know how reciprocal functions work, right? So likewise, so this is what we understood. Reciprocal function of sine x is cosec x. Then reciprocal function of cos x is going to be sec x. Then reciprocal function of tan x is going to be cot x. If you really think about it, this is nothing but 1 divided by sine x. If you really think about it, this is nothing but 1 divided by cos x. And this is going to be 1 divided by tan x. So plotting will come later. Okay, so now this is fine. Now the first identity, right? First identity was sine squared x plus cos squared x is equal to 1. That is our first identity. Now, what I'm going to do, this equation number 1, I'm going to divide by sine squared x. Do that one. So this one would be, so sine squared, right? So it's going to be sine squared x divided by sine squared x plus cos squared x divided by sine squared x equal to 1 divided by sine squared x. So sine squared x divided by sine squared x is 1 plus, we will leave this one in this way, cos x like this. This one is 1 divided by sine x, the whole thing squared, right?
Yep.
So note, now sine x, the whole thing raised to the power 2 is equal to this. That is the notation. Now think in this way. If this is x, right? So this is x and r. This is going to be r sine x. This is going to be r cos x. Now I'm going to write tan x here. Okay, let me change the question a little bit. So let me give you some numbers here. So AB, right? So sin x is equal to A divided by R, agree? Cos x is equal to B divided by R, right? So what is tan x? Tan x is equal to A divided by B. Now what we will do, we will take sin x and divide by cos x. If I do that, sin x is what? Sin x is A divided by R. Cos x is what? B divided by R. What is the answer? A divided by B. Now you will see A divided by A is what we got here. So tan x is equal to sin x divided by cos x. Right? Now that is important. So we know that now. We know that tan x becomes sin x divided by cos x, so you can universally use it. Now, when it comes to reciprocal, so what is the reciprocal of tan x? So obviously reciprocal of tan x is cot x, right? Yeah.
Yep.
So actually cot x is 1 divided by tan x. So what is tan x now? Sin divided by cos, right? It comes like this, right? Yeah. Now simple algebra, this is going to be cos x divided by sin x. Simple stuff, right? Now, okay. So now we know this. I'm doing the same thing again and again, so you will understand better. This we know, reciprocal concept. Now what is tan x? Tan x is equal to sin x divided by cos x multiplied with cot x is equal to cot x is equal to cos divided by sin.
Yep.
Can you see cutting? Cancellations becomes 1.
Okay.
Right? So now we go back to our simplification here. So I was here, right? Now you can see cos divided by sin here. Cos divided by sin, you understand this is cot. 1 divided by sin, you can see that is going to be cosec. You replace it, right? So if you replace it, you get, so what we had was 1 is equal to cos x divided by sin x, the whole thing squared, plus, what was that?
It was 1 plus.
Yeah, 1 plus, yeah, plus 1 plus 1 plus. And then here you get 1 divided by sin x, the whole thing squared, no? Good. So finally this becomes 1 plus cot squared x is equal to cosec squared x. That's the second equation. So not a big deal. So this was derived from the original one. So original equation you divide by sin squared, you got this one.
Okay.
Now I showed you the process, but you have to know the process. No need to remember anything, but this you have to know as identity. This identity again, no matter what x value is, you can use. X can be 30, 40, 50. This identity always holds true. Right? That's a beauty. Okay. Next. Right? So again consider 1 is equal to sin squared x plus cos squared x. Now earlier we divided this by sin squared, no? Now we will divide this by, this is our first equation. First equation we divide by cos squared x. Okay, so if you do that, you should get 1 divided by cos squared x is equal to sin squared x divided by cos squared x plus 1, right? So 1 divided by cos squared x is sec squared x is equal to, this is going to be tan squared x plus 1. So this is our third identity. The third identity. So the first set is done. Set number 1. Set number 1 is done. So what we did, we simply derived this one from the right angle triangle. Then we divided this by sin squared and cos squared, right? So when you divide this by sine squared, we got this one, 1 plus cot squared, right? So it's going to be cos sec squared x is equal to 1 plus cot squared x, right? Then we got after sec squared x is equal to 1 plus tan squared x. Yeah. So these are identities. These are the initial identities, right? So we call it set 1. Right? So this is fine. Now we are talking about the second set after. Set number 2. Set number 2, proof not needed. Proof no need. Why? Because all of these have geometric proof. Like you make a triangle and then do all of these things. Geometric proof. Right? They have a geometric proof. Okay. Now, this set number 2 is called double angle formulas. Double angle formulas. This is so simple. We have to know this. Sine 2x, double angle, right? 2x means double. Is written as 2 sine x cos x. Now the idea is this 2 is always, it is 2. Idea is 2x becomes x and x, double angle. So simple. This proof is a geometric proof, not in syllabus. Now, if I give you example, suppose you have to simplify sine 8x, right? We have to understand the idea. Then it should be 2 sine 4x simple. So what are the use of this? Use of this is this. Suppose you have sine pi divided by 2 or pi divided by 2. So if you want, you can write this in double angle. So it should be 2 sine pi divided by 4 cos pi divided by 4. That's it. Right? Use cases we will see in the future. Once you know that, that's it. So this is our, now I think fourth one, right? Fourth one in set 2, fourth one. So common sense tells us if we have this double angle concept for sine, we should have the double angle concept for cos as well, tan as well. But proof is not needed. We have to know that, right? Yeah. So these things will be there in the data book as well. So nothing to worry about it. So cos 2x. Cos 2x is given to you in this way. Cos squared x minus sine squared x. And that is your fifth one. Cos squared x minus sine squared x.
Okay.
Yeah, so this is given. So you can see double angle 2x becomes x and x. Right? So that's the observation. Yeah. Now, we will try to understand few modifications, right? Few modifications. Okay. We know that 1 is equal to sine squared x plus cos squared x. Right? Now what I'm going to do is this. You can see cos squared x here. I'm going to subtract cos squared x from here, which is going to be 1 minus sine squared, right?
Yep.
Yeah. So I'm going to replace this guy here. Yeah, it's just manipulation. If I do that, you understand this whole thing becomes sine. Because you have sine here, you have sine here, you have 1 here. cos is,
Yep.
cos is going to be disappear. Similarly, if you isolate this one and then replace it here, this whole equation is going to be cos. Right? So let me do that first and then we'll discuss. So to reach there, what I'm going to do, I'm going to isolate cos squared x, which is going to be 1 minus sin squared x. Yeah. Then I'm going to again isolate sin squared x. That's going to be 1 minus cos squared x. Cool. Now, what I'm going to do slowly is I'm going to replace that. So meaning replace cos squared x. Okay. So cos 2x is equal to cos squared x here, right? That would be 1 minus. So I'm going to replace that 1 minus sin squared x. Then the original sin squared x, I'm going to put it here. This guy is nothing but this. If I do that, it's going to be 1 minus 2 sin squared x. So cos 2x. Easy. Now, if you analyze it, what we obtained was, we wrote cos 2x in terms of sine only. In terms of sine only. Easy. Now we do the same thing. Replace sine squared, right? So we'll do that. So replace sine squared. Now if you do that, so we are here, cos 2x is equal to, we leave cos squared x, then sine squared is going to be replaced. So I'm going to put minus here, bracket, sine squared is 1 minus, right? So carefully do that, 1 minus cos squared x. Agree? Like that. Now you can see here minus minus positive, so it's going to be 2 cos squared x minus 1. Again, a similar structure. This is nothing but cos 2x in terms of cos x only. Okay. So again, what we did was, we got the, in set 2, we got the first identity that comes from a proof. Then we use this first identity, first identity to do the substitutions. That's what we did. This process, at least you should see in this in VCE. No one is going to ask, okay, do this. It's just you knowing these things.
Yep.
The idea, right? Okay, set 2. What is set 2 now? Set number 2. In set number 2, we had cos 2x is equal to cos squared x minus sin squared x. Also we had the second version, once you do the substitution, 2 cos squared x minus 1, which is this. Also, we had 1 minus 2 sin squared x, which is the previous one. So you can say this is our fourth equation, you can say this is our fifth one, you can say this is our sixth one.
Yep.
So that's all about cos 2x double angle formulation. So there are so many examples. Example would be Suppose cos pi divided by 4, right? Suppose cos of pi divided by 4. Right? So you can write this one as 1 minus 2 sine square pi divided by 4, correct? Pi divided by 2. Pi divided by 2. Pi divided by 8 actually, not 2.
Yeah.
Right? Now by looking at this, tell me why this equation is important. This equation is important due to a very simple and clear reason. Cos pi divided by 4 we know, which is 1 divided by square root 2 from our trigonometric table. From grade 10 we do that. But this is going to be 45 degrees, right?
Yep.
This is going to be 22 point, half of it, right? Fine. Suppose we need to find the sine value of 22.5. Do you know that? No, not from the trig table. So we use this technique. So we understand when you double it, it's going to be this. That we know. So using this, we can find this value. That's the use in the future.
Oh, okay.
Simple thing, yeah. So if you do that, so this is going to be 1 divided by square root 2 is equal to 1 minus 2. This guy is going to be, now what? This guy is going to be sine squared pi divided by 8, right? So now we'll do a simple simplification. You bring this one to the other side. So 2 sine squared pi divided by 8 is equal to 1 minus 1 divided by square root 2, yeah? Now, if you take this dude and simplify, it's going to be square root 2 minus 1 divided by square root 2, right? Yeah? If you want, you can rationalize it. So it's going to be 2 here. This is going to be 2 minus square root 2, right? You can rationalize it in that way. Now what you can do, you can see these two cross multiply. So then once, if you do that, you get sine squared pi divided by 8 is equal to, you cross multiply, 2 minus square root 2 divided by 4. Yeah. So what is sine pi divided by 8 then? Sine pi divided by 8 is square root of this, right? So that should be 2 minus square root 2, the whole thing square root, divided by 2. See, this is how you find sine 22.5. In methods, nobody knows how to do that. There are tools in spec so that you can think so many things. So that's why I'm always saying, if you do that, this thinking is fixed. Yeah, all good. So now you know the use of it, right? So if you need cos, again you use the other one and do that, right? Okay. Right. Okay. So now we understood sine 2x, cos 2x. The next one is tan 2x. Okay. Again, this is given to you. This is 2 tan x divided by 1 minus tan square x. Okay, this is 1 minus tan square x. So this is given to you. No problem. Given to you. So, right. We'll do a question here. We'll do a question. Using above identity, find the value of tan pi divided by 8. So it is now like this. Tan 45 is equal to 2 tan pi divided by 8 divided by 1 minus tan squared pi divided by 8. So this is 1. Yeah. So we can say let x to be tan pi divided by 8. How do you understand that? Because you have tan squared, right? So this, if this is 1, you can cross multiply this whole thing. Right? So if that happens, you get 1 is equal to 2x divided by 1 minus x squared. See? Yeah, now cross multiply. So 1 minus x squared is equal to 2x. Understood?
Yeah.
So now quadratic, right? So it's going to be x squared plus 2x minus 1 is equal to 0.
Okay.
It's quadratic now. So now solve for quadratic. What is the quadratic now? It's going to be minus b plus or minus b squared 4 minus 4ac is going to be plus 4a. 2. So x is equal to, now simplify this a little bit, plus or minus, it's going to be 8. 8 means 4, 2. So it's going to be 2 square root 2 divided by 2. So it's going to be minus 2 plus or minus square root 2, right? So what is x now? X is tan pi divided by 8. So tan pi divided by 8, which is x, right? Which is this answer. So that's how you find tan 22.5.
Okay.
So now you can see these are new things, but you can see it's just like very fundamental math is in. You will see in specialist math throughout, the content is specialist content like this, but 80%, 70% things are going to be fundamentals inside. Okay. So what we understood today we did set 1. Okay, sine squared x 1. Also we did what? 1 plus tan squared x is equal to sec squared x. Also we had 1 plus cot squared x is equal to cosec squared x. Now I remember this. Why? Because I see the patterns, 1 tan, 1 cot, those things, and I can immediately sign this by sine squared. So when I know that's going to be 1, then I divide this by sine squared, then I know it's going to be cot. So from here, from the first one, I can quickly get these things in my mind. So I don't remember these things. I know the process. Set number 2. Set number 2, yeah, sine 2x is going to be 2 sine x cos x, then cos 2x. Cos 2x is cos squared x minus sine squared x. Then the other one is 2 cos squared x minus 1. Then the other one is 1 minus 2 sine squared x. That is what we proved. Then finally we did tan 2x. That would be 2 tan x. So tan 2x is equal to 2 tan x divided by 1 minus tan squared x. So there are 6 equations in 2 sets.